Section 7.4a, matrices and systems of equations. Some vocabulary that you're going to need to be familiar with matrices. First of all, a matrix is a rectangular array of numbers and or variables. Rows in a matrix are the horizontal entries, which means they go left and right. Columns of a matrix are the vertical entries, meaning they go up and down. You have to separate rows from columns. Think of columns on a building. Columns in front of a building go up and down, just like columns in a matrix go up and down. The order of a matrix then is determined by the number of rows and the number of columns. This is read as M by N. M, or the first number, is always the number of rows. The second number is always the number of columns, which is why you must know the difference between rows and columns. Rows go left and right, columns go up and down. Determine the order of each one of these matrices. Matrix A has 2 rows and 1 column, so therefore it is a 2 by 1 matrix. When you name it, use a letter to name it, and then the subscript on the letter tells the number of rows by columns or the order. Matrix B has 1 row and 1, 2, 3 columns. Therefore, it is a 1 by 3 matrix. Matrix C, 1, 2 rows, 1, 2, 3 columns, 2 by 3 matrix. Matrix D, 1, 2, 3 rows, 1, 2 columns. So matrix D is 3 by 2. Example 2. Write an augmented matrix for each system. When we're talking about an augmented matrix, matrices are going to allow us to solve systems of equations very, very quickly, especially using a calculator. In a matrix, each equation is represented in a row of the matrix. Each variable in an equation is represented along with the constants in a column of the matrix. So looking at this matrix here, there's X, Y, Z, and a constant. That tells me that there are going to be 4 columns. There's 1, 2, 3 equations, which tells us there's going to be 3 rows. So our first row is the coefficients in order from left to right. So 1, -4, 3, and then we put a dotted line to show where the equal sign is, and the constant goes on the other side. Second equation is the second row. So -1, 3, -1, -3. Third equation, 2, 0 because there is no y, -4, and 6. So as I look at this matrix, here's equation 1, here's equation 2, here's equation 3. We have an x column, a y column, a z column, and a constant column going up and down. Matrix or letter B. First line is the first equation, 1, 3, 0, dotted line for the equal sign and the constant. Next row, equation 2, no x's, -1 y's, 4 z's, and -2 for a constant. And the last row, third equation, 1, 0 for the y's, -5, and 0 for the constant. Those are the augmented matrices for each one of those systems. When we talk about a matrix, then, we can perform elementary row operations on a matrix. There are only 3 things that we can do. First thing that we can do at any time is interchange 2 rows. So looking back here, think about if I were to interchange these 2 rows. What is really happening when I interchange 2 rows? I'm simply rearranging the order in which I write these 2 equations. So this second equation would now be the first one. First one would be the second one. Does it matter the order that equations are written in when we solve a system? No. Therefore, we can interchange two rows in a matrix at any time as well. Second thing that we can do is we can multiply a row by a constant but not 0. In an equation, we do this all the time when we have fractions. We multiply by the common denominator to clear out the fractions. If there's decimals, we multiply by some power of 10 to get rid of the decimals. So we can multiply by a constant at any time as long as it is not 0. And the third thing that we can do is we can add a multiple of a row to another row, which is the exact same thing as elimination. Let's take a look back here. Looking at this system, if I wanted to eliminate x's using these two equations, what would I do? Well, I'd multiply this equation by 2 and add it to the third equation. So in matrix terms, what that is that's taking 2 times row 2, since that's equation 2, and then adding it to row 3. That's how we would describe that operation within the matrix, which is the same thing as what we do in elimination to eliminate x's. Again, those are the only 3 things that can be done. So looking at the next example, when we want to identify or describe the elementary row operations, first thing I would do is look at what stays the same. In this matrix, row 3 stays the same, so we know that nothing is involving row 3 here. If I look at the top 2 lines, row 1 and row 2, we can see that row 1 and row 2 have simply switched positions. Row 2 is now in row 1's position, and row 1 is now down here in row 2's position. So all we have done here is switched rows 1 and 2, which we can identify with that symbol. Letter B. If we look at letter B, we can see again that equation 3 or row 3 has been unchanged. We can see that equation 2 or row 2 has been unchanged. The only thing that has been changed is row 1. What has been done to everything in row 1? Most students would say right away, well, it's being divided by 2. Remember, the only operation that is defined, though, is multiplication. So dividing by 2 is the same as multiplying by 1/2. So we've multiplied equation 1 by 1/2, or 1/2 times row 1. Third one, we can see that row 1 is unchanged. Row 2 is unchanged. Therefore, we're not switching any rows, so we can eliminate that. Row 3 has been changed. Are we multiplying row 3 by a constant? No, because we know we cannot multiply by 0, and this 2 turned into a 0, so we know we are not multiplying. The only thing that that leaves us with is the third thing here, adding a multiple of a row to another row. Let's take this first matrix here on the left in part C. Remember, row 1 represents x plus 2y minus 4z equals 3. Row 2 is 3y minus 2z equals -1. And row 3 is 2x plus y plus 5z equals -2. If we look back over here, this 2 entry has turned into a 0. Remember though, this column represents our x's. So essentially what we've done is we have eliminated the x. What can we do to eliminate the x? Well, if I want to eliminate x's over here in these 2 equations, I would multiply this equation by -2 and add it to this equation. So in matrix terms, in terms of rows and columns, what are we doing? We're taking -2 times equation 1, which is in row 1, and we're adding it to row 3. We can go through and check all of these. Take -2 times 1, add 2, and we get 0. Take -2 times 2 is -4. -4 plus 1 is -3. -2 times -4 is 8. 8 plus 5 is 13. And -6 minus 2 is -8. So we can see that that is what we are doing. We took -2 times equation 1, added it to equation 3, which in matrix terms, -2 times row 1 plus row 3.